Sometimes we need to create new functions and we can't use existing functions. And in this video, we're going to create a new function for cyclic neutropenia. This is a blood disorder characterized by periodic fluctuations in the density of neutrophils. The density of neutrophils reaches about 2,000 cells per microliter of blood, and it has lows near zero. The period of fluctuation is about 3 weeks. And so what we want to do is find a function n of t that describes the amount of neutrophils in the blood as a function of time in days, assuming that the density of neutrophils is highest at day equals 0. And so the relevant quantities are here. The maximum is 2,000, the minimum is 0, the period is 21, and the maximum is at day 0. And so if we have a fluctuating function, we think of sines and cosines, but which of those we choose depends on the criteria that the maximum is at day 0, and the cosine function has a maximum at 0. So that'll be our base function. Let's remember how we do shifts and stretches, okay? So y equals f of t plus c is an upwards shift. By c. Y is equal to c times f of t is a vertical stretch by c. And y is equal to f of t over c is a horizontal stretch. By c. So we're going to use all of these three things in what we do here. So our base function is the cosine function. And if we plot this out, this lies between 1 and -1. The first thing we want to do is shift this up so that the minimum is at 0. So we shift up. And in this case, we choose c is equal to 1. And our function is cosine of t plus 1. And now this has a maximum of 2. And it looks like this here. Now the maximum given over here is 2,000, so we want to a vertical stretch. And we choose c is equal to 1,000 for that. So we have 1,000 times cosine of t plus 1. Okay, and then we need to put the period in here, which is 21 days. The period for the cosine function is 2 pi. And so we want to do a horizontal stretch. And here we choose c to be 21 over 2 pi. 21 being the number of days that we want. And so our formula then becomes n of t is equal to 1,000 times the cosine of t divided by 21 over 2 pi plus 1. And we can simplify that if we want to and write it as 1,000 times the cosine of 2 pi t over 21 plus 1. And so that gives us our function for the cyclic neutropenia.